First of all, thank you so much for having me here today. My name is Ubiratan. It's an unusual name from my country, Brazil. I am from Brazil, and I nowadays live and work here in Barcelona, Spain. And I work at N26. And today I will be sharing a bit about our experience on automating Gradle benchmarks and pretty much provide some context, and we will have a live demo as well. Hopefully everything will work fine. Let's see. So yes, sharing a bit of context here. I work at N26. We are a fintech here in Europe. We have this link here, kind of mandatory slide, I guess. I'm kind of compelled to put this slide, but yeah, sorry. Go for our page and pretty much learn about which positions we have. But more than that, we have here an Android project, right? And we have a main product, which serves kind of a couple million of users. And pretty much, I don't know, it's very well known here in Europe in the fintech space. And in order to deliver this particular product, we have nowadays around 35 Android engineers, which work in a monorepo, hosting more or less 1 million lines of code. We have inside this monorepo more or less 380 Gradle modules. We have more or less 20,000 tests, pretty much talking about all sort of tests, unit tests, expresso tests, integration tests, not the end-to-end, but okay, all sort of screenshot tests as well. So we have tons of tests. So yes, so we have a big project. We don't have, let's say, a super big team right now, but we are growing. And yes, and as so many teams out there, we face some issues here and there, right? Especially with Gradle builds. In order to enable our engineers to deliver faster and pretty much, let's say, code with confidence over our gigantic project, we have a platform team inside N26, right? We have several groups inside this platform engineering segment, as we call it. And we have groups like observability, connectivity, scalability, and so on. And we have client platform. And inside client platform, we have 4 teams: iOS core, web core, NXD core, which pretty much is in charge of evolving our design system. And we have Android core. Our Android core team is pretty much formed by 4 engineers, all of them living here in Barcelona. 2 of them nowadays in parental leave, awesome. So we are actually 2. And yes, and we are in charge of kind of handling a couple of stuff like our core libraries that pretty much all feature teams use in a regular basis, like, I don't know, our navigation system, our deep links subsystem, so on and so forth. We are pretty much in charge of driving the code test build deploy infrastructure, which means that we are pretty much owners of the build system solution that we use, which is Gradle nowadays. We pretty much own and drives all sort of experiences regarding the CI/CD system, which is Bitrise and our custom release train automation. We do bi-weekly releases. And most important is that starting 2022, we realized that improving Gradle builds would be a top priority for us. It has been the, let's say, the #1 complaint for Android engineers in the past 2 years, I guess. So yeah, so eventually we are throwing some money into the problem by buying new machines and etc. But okay, but we have more opportunities there, not only by, you know, delivering more hardware and more horsepower to people, but doing something better. So yes, everything here will click in just a few minutes, right? Inside our client platform team, we use something called continuous discovery, right? This is our framework in order to drive our initiatives, right? We have a product vision over this experience or this journey around code, build, test, and deploy / delivery. And we work with these sprints or super sprints or I don't know, cycles of 6 weeks, right? And our our cycles are pretty much divided into four phases, right? 2 weeks for discovery, 2 weeks for delivery, 1 week for cooldown, and one week for housekeeping. And why is that important? Because particularly the way we work inside our team, inside client platform in general, is driving our mindset with this continuous discovery framework, where we try to map things inside the opportunity space based on real customer needs or real needs from our engineers, and eventually moving into the solution space based on ideation, research, and experimentation, right? And putting that in other words, when we are talking here about opportunity discovery inside the continuous discovery framework, we are pretty much talking about the scope, about what we want to do, and which value proposition we are actually uncovering for our engineers. And when we talk about solution space, we are talking about how we plan to address those particular value propositions, right? And particularly, we don't talk only about how we plan to, to deliver things, but actually we also drive some measurements around confidence about the solutions we propose and about the impact that a particular solution may deliver inside our product, so to speak, right? Our platform as a product. And yes, so a quick reference here. I am not kind of, earning. Oh no, I am not kind of earning a single pen here, but we take a lot of inspiration from this book, from this girl of Silicon Valley, more or less like product expert, I guess. So I really, really recommend for everyone that's curious to learn about this particular framework. And yes, so really, really recommend it. So yes, so now going back to the slide that jumped ahead of time, why I am sharing all these pieces of information, right? Because when we as engineers, we are pretty much driven by solutions. And eventually we just want to go there and drive the solution. We don't care that much. I mean, I don't want to generalize here, but in a rule of thumb, eventually we skip the part where we wanted to access if the solution that we are working on actually will work as we expect. And if the solution will work at all, how much impact that solution will drive, right? Particularly, there is this tool / practice / concept of pre-mortems, right? Which means that, okay, during the solution discovery, we wanted to make it sure that our solution will work. And then when we are talking about things around Gradle, we want to make it sure that when jumping into a new initiative, let's say, I don't know, improve our dependency graph, we wanted to make it sure that that particular solution will work, right? So we want to validate that beforehand. Otherwise, we will just discard that particular solution. And this is what we call pre-mortem, right? We evaluate beforehand in which situations that particular solution will not work. All that story pretty much to contextualize why we went for Gradle Profiler, right? When accessing which tools we could use in order to drive the discovery process inside our platform, we realized that Gradle Profiler could be a really good fit, right? So here you have the GitHub page of this tool with install instructions using, let's say, Homebrew or, I don't know, a directed download or whatever. And yes, I won't, let's say, dig a lot into Gradle Profiler because the tool, when we talk about benchmarking, is not that hard to use. Actually, it's quite simple, to be honest. And yes, and it's a very powerful tool that can do way more things than just benchmarking builds, right? It can, for instance, profile builds. And profiling is something different than benchmarking, and I won't cover any situations around profiling in this talk. But yes, so it's something that it's worth to learn about. And yes, eventually what we are interested here is the benchmarking capabilities of this tool, not covering multiple build systems or alternative build systems in the Android ecosystem, like, I don't know, Bazel or Buck or others, but covering Gradle and controlling how pretty much Gradle is supposed to execute, right? One of the good things about Gradle Profiler is that regarding the build system under evaluation, it outputs some reports, particularly the CSV file and the HTML file, right? Especially the CSV file will be super useful for us because it's the format that we have in order to crunch that data afterwards. So yes, how do we invoke Gradle Profiler if we eventually install it with Homebrew, let's say? So the easiest way, in my opinion, is pretty much specifying something called a scenario file, right? We will see some examples of scenario files in just a few minutes, right? But the invocation is quite simple, right? We pass this flag where we specify that we are driving a benchmark. We specify the Gradle project, the outputs directly where Gradle Profiler will write the outcomes, let's say the CSV file, the HTML file, the profile, the logs from that particular build. And in this case here, I pretty much drive the execution based on this scenario. So yeah, so if I execute this particular benchmark, and let's say that my scenario file kind of, specify 5 different or 6 different Gradle tasks, I will have this particular HTML file, right? Which is more or less like a report. So we have here, let's say, the execution times, how the build behaved during several different executions, I don't know, some metrics from statistics like, I don't know, the quartiles, the standard deviation, and so on, mean, right? So yeah, so we have some data here, and which is cool, in my opinion. And yes, back in February this year, we evaluated that Gradle Profiler could be a good fit in our solution discovery process, right? And yes, and we realized that the data that Gradle Profiler generates could be ideal to target the situation that we wanted to achieve. Now, not the implementation details, right? Because the implementation details eventually would be different according to the implementation path. Maybe I can give you an example here. Let's say that I wanted to estimate how much it would worth to invest our time in enabling configuration cache in our build. Okay, so from the implementation details perspective, I just wanted to make it sure that I don't have any sort of Gradle plugins that are incompatible with Gradle configuration caching, and turn on that particular flag and drive a couple of benchmarks to measure, right? In order to do that, I don't need to couple with the implementation path in order to estimate. I can just remove all non-required Gradle plugins or disable them, disable the tasks, do, I don't know, anything that it's not super accurate, have configuration caching enabled, benchmark the most common tasks that our engineers have to run in a daily basis, and then I get some estimation. It's not the perfect estimation, but eventually it's good enough in order to help us to drive the confidence of that particular solution, right? And eventually, that particular confidence will be a high level confidence, right? That we will use inside our calculation score. We use a framework here called RICA, which is pretty much RICE, but we exchange the effort by something that we call appetite. And yeah, so this is pretty much a metric that it's quite famous around product people, and we use this metric when scoring solutions inside our team. And most or last but not least, sorry, when we talk about the benchmarking process, we eventually will uncover implementation paths. So let's say, mentioning the example I just shared, that I am trying to figure out how much configuration caching will benefit our Android engineers. In that particular case, I can easily learn, let's say, which plugins are not compatible with configuration caching at all. I don't need to commit with fix the situation around those particular plugins, but at least I can learn about those plugins, right? So when pretty much evaluating the implementation path, I have some place to start. So yes, so Gradle Profiler all the way. We started doing some benchmarks here in our project, right? And in order to drive those benchmarks, we started simple. We started, for instance, with a scenario file like this one, which would be an input for that particular tool, as I've shown to you a few slides ago. Here at N26, we use something called sample apps or single feature apps, right? It's a technique quite, let's say, quite present in large Android projects, where we pretty much try to not build the entire project in order to allow an engineer to run one particular screen or one particular feature, right? So yeah, so we pretty much pack this small app, or as we call it, this single feature app or SFA. We pack this particular app in a very opinionated way, with a simplified login, with a sort of simplified verifications and so on. But that particular app is enough in order to our engineers to iterate faster. And yes, and here we have a description of a scenario, right? So we have here the title of that scenario that will help us in order to locate the data associated with the execution afterwards. We have the task that I am supposed to execute, how the Gradle demo should behave, if I should clean that build or not before each execution. We have here the number of warm-ups that we should drive. This is quite important, because the warm-up of a build will pretty much not only hit the Gradle task cache, but also pretty much drive things like dependency resolution and everything. And we have the number of iterations that we want to measure for that particular Gradle task, right? And we can go even further. We can specify, let's say, Gradle args that are specific to that particular scenario or that particular task that we want to measure. We can even drive incremental builds, like specifying which type of changes Gradle should simulate, Gradle Profiler, sorry, should simulate in a given source code file, like, I don't know, this particular Kotlin file, and not only a change, but we can specify which type of change. For instance, an ABI change or a known ABI change, and eventually on top of this change, things can, let's say, drive more impact in terms of recompilation or not for the upstream modules of this particular build. So yeah, so we can do a lot of things, right? So the best way to learn about all the options for scenarios is pretty much going strictly to the documentation of Gradle Profiler, which is pretty much the README page on GitHub for now. So yes, so we can pretty much design a scenario file like this one, drive this particular benchmark, and collect the outputs of that particular benchmark. But the important part here, and here is where this talk is different from other talks around this topic, is that we don't do benchmarks around, let's say, tons of changes, right? We eventually do the minimum amount of changes required for our solution. And of course, pretty much we branch from our trunk branch in GitHub, in our case, master branch. We branch from that particular master branch, and pretty much we, I don't know, commit once, twice, all the changes that we need in order to achieve the state that we want for our build and drive the benchmark. So yes, sounds fair, right? So by executing this task, I will executing this command line, I will pretty much collect a set of outputs, the HTML file, the CSV file. Super cool. But we learned that this is not enough. We eventually want also to benchmark the baseline state. We want to benchmark not only what happened before our changes, but actually how things were before the changes. Sorry, I misspelled here. We don't want to benchmark only after our changes, but also before our changes, because then we can compare somehow, you know? And Gradle Profiler has an option that allows you to kind of check out a particular commit as part of an incremental build. But we don't use this option, and I will dive into that later in this presentation, right? But right now, let's stick with this mental model, right? We learned that in order to measure before and after, we should have this Git branching model in our minds. So yes, we should have this, and eventually we should use 2 passes in order to drive our benchmarks. So pain points that we started to face. First of all, we were running those benchmarks in our local machines, right? Just to get started. And let's suppose this situation where I have, let's say, 5 scenarios that I wanted to benchmark, right? 5 different Gradle tasks with different switchers or whatever. Let's say that I have 5 warm-up builds, and I have 15 builds that I want to measure, which means 20 builds per scenario. I have 2 passes to follow because I want to benchmark the changes that I just committed in my head branch, but I also need to benchmark what is the status quo in the particular measure-based branch. And let's say that, okay, for each scenario, for some reason, I need 2 minutes per build. That means more than 6 hours building in my local machine, which is a huge pain. I mean, I myself, I never drove a benchmark that took so much time, but I drove a benchmark that took, let's say, 2 hours, and it was super painful because we have a lot of issues, right? Okay, so I didn't have this M1 Mac, we call here internally the M1 Macs, our McLarens. The whole I didn't have a McLaren back in the day, So yeah, so it was super painful, and then I don't know. I had to do this, let's say, in the very edges of a working day, because if I started a benchmark during the working hours, let's say in the middle of the day, eventually I had to jump into a meeting, and then and then I would start to multitask alongside with the benchmark, which pretty much allocates more resources from the machine, or eventually the Google Meet chat would compete by the machine resources with the build. So super painful process, very inaccurate results, or eventually distorted results here and there. So yeah, so we realized that we could and we should do better. So first solution, let's delegate executions to CI machines, right? So first, let's say idea, and in the end of the day, we managed to do that, but I will also dig into this in just a few minutes. So yeah, so eventually, let's say that we managed to get the results, right? So we managed to get the numbers from the two benchmarks, the one regarding the changes that I just tried or the changes that I am evaluating during my discovery process and the status quo. Eventually, I could copy paste these two CSV files in this lovely Google Sheet. Amazing, right? And yes, we can get that much from that Google Sheet, right? But I can rearrange these data and I can have something like this, right? I can group the tasks by task name and pretty much define before and after, and I can plot a chart. And this is already something. This is already something that Gradle Profiler does not give us, let's say, in an easy way. And okay, I can figure out that it seems that my modifications in this particular scenario here for this particular task are actually working, because I can see the red line regarding the modifications. I can see that all data points are below the blue line. So this is quite easy to see that we are improving here. But we can, okay, so we are improving. But we can have a situation like this. So I can see that most of the data points from the red line are below the blue line. And we don't have too much noise in the data set. But at the same time, we see overlaps here and there. So how can we make sure that we are improving this particular scenario? So we don't have, let's say, an easy answer here, and eventually the answer could be even more tricky to get in more complex samples where we have, let's say, a lot of noise, or if you prefer, a lot of standard deviation. So something that we learned during this process is that when we face a sample like this, and here I am taking only one particular data set from one of the executions from one task, when we have something like this, we don't see too much things by plotting the data like this. But I can plot the data like this. So here I have something different, because what I am plotting here is not, let's say, the line chart. What I am plotting here is something that we call a histogram, right? So it's pretty much a chart that plots the measure builds or the frequency of the occurrences of each point in the data set in a given range. And when we plot something like this, I don't know if this kind of shines to you or not, but trust me here, this data set could be modeled by something like this, right? The normal curve or the bell curve, right? And this is truly amazing. This is truly amazing, because eventually, if we drive the benchmark in the proper way, let's say not in a super isolated way, not kind of jeopardizing the resources of the benchmarking machine with multitasking, this type of things, the events eventually will be independent enough in order to allow the data set to follow the normal distribution, right? And this is really a mind-blowing insight, because if this is true, this means that when getting data from both samples, from the benchmark, the baseline benchmark pointing to the head base in the master branch and to my actual head commit in my head branch, I can drive something called hypothesis testing. And this hypothesis testing is pretty much the most common statistical test that we have in science, right? And the idea here is that we will sample, let's say, a particular subset of a given population. We will pretty much eventually apply some refinement validation, extract, let's say, the characteristic that we want to measure, in this case, the mean. we will apply something called a probability analysis, and we will be able eventually to get an answer. If I pick another sample, which chance do I have to get the same results? This will become more clear with an example that I have. But before going into that example, I need to at least mention something we use, which is called a p-value, right? And the p-value is pretty much something that we calculate on top of the curve that we use in order to model the data set. For instance, we can use the normal curve, or we can use the bell curve, or we can use the t-student curve, or the t-student distribution, if you prefer. And eventually, the p-value represents the probability of not observe that particular sample again, which means the p-value is the probability of the false positive, right? So if I go back to that particular Google Sheet, and in that particular paired sample, which was, let's say, ambiguous, and if I use the t-test function provided by Google Sheets, holy shit, amazing, I will get a p-value of 0.02, or eventually, okay, 0.03. So that means that we have 97% of probability that the mean for the first data set and the mean for the second data set, they are different means. So what we have here with this number, with this p-value calculated automatically by Google Sheets with a pre-built formula is, okay, we have a high level probability of those two particular means are different. And here we are taking in account the standard deviation for those two particular data sets. And because the data sets are different, and because the second data set is smaller, or actually the second mean for the data set H1 is actually different for the mean of the data set H0, we can kind of, we're actually improving our build here. So we can confirm that, okay, actually the red line that represents the data set of my modifications in that particular chat actually represents a smaller mean. You know? So yes, so here is the point where, let's say, our build engineering meets the data science, right? Because we are, in the end of the day, using one of the techniques from the world of statistics in our build engineering. So we pretty much can drive this framework where we start with a particular Gradle task or a scenario, if you prefer. We pretty much benchmark two different Git commits, one pointing to the modifications on their task, another one pointing to the status quo. We apply the outputs of those two particular benchmarks to the paired t-test, eventually using a Google spreadsheet. We extract the p-value. We pretty much compare with the tolerance that we want to use in order to accept or reject that particular result. And eventually, this number is 5%. It's, let's say, the common number that most of, let's say, hypothesis tests out there use in a rule of thumb. We pretty much compare those values and we drive the conclusion, because if we figure out that the probability of getting a false positive is smaller than the tolerance, we have strong evidence that the means between those two samples are different. Otherwise, we have evidence that, okay, I can't accept that we are actually improving or even not improving, because the only thing that I know is that the means are not equal. Okay. So yeah, and we have variants for that particular test. For instance, a left-tailed test or a right-tailed test, according to the scenario or the situation that I want to access here. So there was a lot of things. I know it was painful, but I just wanted to summarize the challenges that we faced when pretty much starting learning how we should use Gradle Profiler and use those results in a proper way, right? First thing we learned is that running those benchmarks on local machines was super expensive and executions were not isolated. Consolidating the data sources into Google Sheets was a manual process, prone to errors, tedious, not, let's say, efficient at all. And the reliable implementation of those results could be no trivial eventually, because we could have a lot of noise in the samples. And disambiguating in conclusive scenarios or in conclusive outcomes was not trivial at all. And of course, statistics is super powerful, but it's hard. So our solution to pretty much address all of these pain points were automating or shifting left all the way we do experiments on top of Gradle Profiler, or if you prefer, shifting left part of our solution discovery process. How we did that? First of all, we set some goals for us. We wanted to have an automation over this complexity of running benchmarks and generating data and evaluating the outcomes of that particular data. We wanted to make, let's say, Gradle Profiler almost invisible, right? Eventually, our only interface with Gradle Profiler would be the scenario file. We wanted to have fast results. So this is important, right? Because we don't want, let's say, to wait 6-8 hours in order to get a result of a particular benchmark, even when dealing with several scenarios and eventually super compute intensive scenarios, like, I don't know, building the full app over and over. We wanted to have a self-service solution, and we wanted to have a non-blocking solution, right? Which means we wanted to work, let's say, in the async await way. So I just fire the request of my experiment in the tooling, and eventually I will get the results in some point in time, callback style. Our solution for this was a tool that we call internally like Machete Benchmarks, right? Machete is pretty much the code name of our Android project. So here we have the companion tooling for benchmarking our project. And we have 3 internal subsystems inside this solution. All of them are named, I name it after constellations. So we have Sculptor, Fornax, and Aquila. And here it's quite simple to figure out what's going on, right? So Sculptor and Fornax are in charge of data generation. And they pretty much use most of the things that we are used to. They use, for instance, the Android SDK, Gradle Profiler, shell scripts, and they run inside some self-hosted GitHub Actions machines that we have. And we opted to pretty much isolate completely the execution of such benchmarks in our self-hosted machines, right? To pretty much minimize all sort of interference. And we have Aquila, which is in charge of data evaluation. And Aquila is built with Python, and it pretty much it's designed to work, but not exclusively like that, but it's designed to work in with something called Jupyter Notebooks, right? And we will pretty much see that in just a few minutes. And eventually inside a Jupyter Notebook host environment like Google Collaboratory. So yes, so a bit of each one of these tools, right? So Sculptor is pretty much the set of scripts that prepare the vanilla machine in order to allow that machine to be ready to drive the benchmark. Fornax is pretty much the set of scripts that make the machine hot, the benchmark machine hot. It wraps the Gradle Profiler, wraps Git as well, and drives the execution in an opinionated way. And Aquila is a small Python SDK. And this Python SDK will pretty much parse the 2 CSV files that we will grab from the benchmark execution. We will pretty much pair the data points, and we run the parity test on top of SciPy and NumPy, which are pretty much consolidated tools in the data science world. How we do this? So the workflow, the self-service workflow is quite simple. The engineer, like me, will pretty much code some changes in our monorepo will pretty much push that particular red branch with the open the pull request. You just need to push that branch. It will go in the Machete Benchmarks repository. It will trigger a workflow passing the name of the branch that was just pushed in the remote and the name of the scenario file that we want to execute. Eventually, the scenario file is already there by a convention, or I can just raise a pull request and add a new one. That particular benchmark workflow will drive the benchmarks in a very opinionated way and will output a zip file with all the contents that are required for us to upload that file in the Google Collab. What is Google Collab? Google Collab is a tool. I will show Google Collab to you in just a few moments, but it's a tool offered by Google for free, right? And yes, it works alongside with Google Drive. It's super nice. But yes, so we have two manual steps in this self-service solution, right? The first manual step is pretty much kicking off, the workflow, the benchmarker workflow. And the second manual step is pretty much uploading the output file directly into Collab. We could have automated everything, but then it's quite tricky because our Google Drive account is kind of shared with other teams. Then we would need to get a service account. I don't know. Okay, so it's doable to have, let's say, a manual upload after, let's say, not wasting hours and hours of my own time, waiting for a benchmark in my local machine. How the benchmark workflow works? It will pretty much take in account that particular situation that I described a few slides ago, and it will pretty much invoke Gradle Profiler 2 times into 2 different child workflows. And why do we? Because we want those things to run in parallel. This is the reason why we don't use the Git checkout option in the incremental build. Because if we use the Git checkout option when specifying an incremental build using the scenario file, that would force us to pretty much do things in only one pass. And if you want to do things in 2 passes in parallel, then we want to go like this. So what the benchmarker workflow does, it pretty much calculates the proper commits, the head commits, the bash-based commits. It pretty much knows, which parameters to pass to Fornax in order to drive the opinionated benchmark. It also packages all the Python codes that we have in a proper installable pip file. And the contents of the zip file that we will upload to Collab are, the 2 CSV files related to each one of the executions and the Python SDK. And on top of that, this is just let's say some snippet of code, because there is no code in this presentation, right? So some code for you, if you were willing to see some code, here you have some Python code in an Android conference. Amazing. So here is pretty much the heart of the Aquila tool, where we have this benchmark evaluator class. So we have here a method pretty much to align the 2 samples. And last but not least, we have the method to pretty much extract the outcome. And when we drive the extract outcome method, we use here, in order to drive the means, we use NumPy, and in order to drive the parity test, we use SciPy, right? And eventually we calculate the quality of those data samples based on that. Cool. Then Jupyter Notebooks. What are Jupyter Notebooks? Jupyter Notebooks are more or less like embedded, not embedded, but it's an easy way to mix markdown text with Python code. More or less like, something that you read once, and yes, it's more or less like a notebook or like a diary of an experiment that you run. It's super popular among data scientists and I would say almost unexplored among platform engineers. So yes, it's quite easy to install. We can pretty much run in the browser and so on. But most important, we have a super easy way to run Jupyter Notebooks using this tool that Google offers for free, that works pretty much inside Google Drive, which is called Google Collaboratory, or Google Collab if you prefer. And here we have, for instance, what we can do with Python code, something that I don't have even an idea how to do this, let's say with Kotlin in an easy way. I know that we have the Kotlin kernel for Jupyter and so on, and okay, but man, come on, I don't care about type safety here. I just want to get my problem solved, and what I wanted is, let's say, to have this proper tabular view where I can figure out among the scenarios that I just executed, which ones are actually improving or each ones are actually not improving at all. So, and this tool is driven by a Python framework or a Python library called Pandas, right? Another thing that I do is pretty much plot charts in a very easy way. Something that I have no idea on how to automate inside a Google Sheet. Eventually it's possible, but eventually as well, on top of this matplotlib tool from the Python ecosystem, it's also super easy. And yes, after all these amazing content and pretty much exhausting content, it's time for a live demo. And I have no idea if I am on time or not. I think I am late, but yes, let's do this. And to my live demo, I will pretty much open the browser. Amazing. And I will take an inspiration of this tweet. This is a tweet from some months ago by one of the Square engineers, right? This guy is kind of, I don't know, author of the Anvil tool. I mean, it's super impactful in the Android ecosystem and the Android community, I guess. And I I recall from some months ago that I read this, and then we had there, set your min SDK to 24 locally for faster builds. In some scenarios, we've benchmarked an improvement up to 17%, right? For compatibility reasons, DAX intake is longer with a lower SDK. So this looks like a super good quick win for us, right? Because nowadays, at N26, I am supposing here, right? Nowadays at N26, we use min SDK 23. So maybe we can just tweak our build logic in order to push min SDK 24 when engineers are building locally. And in the CI machine, we will still use min SDK 23. Eventually, this solution will have pros and cons, but we can gain some things in terms of build time. And we have a discussion here. Okay, I think that Android Studio did this automatically when you have the target device connected, probably, but we often build in CLI, and this will then lead to a cache misses if we don't use the same version everywhere, blah, 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 blah. So yeah, some snippet here in order on how to detect the IDE and drive the build logic. And eventually we even have this one here from this year. Why not min SDK 26 to avoid the sugaring at all? Awesome. So we have this situation, and let's benchmark it. So to benchmark this, I already have here, I hope that I didn't, I hope I don't get, let's say, a push from security by sharing images from our internal GitHub, but it should be fine. So yeah, here we have the Machete benchmark repository, and here we have the workflows that we use GitHub Actions with isolated, not shared with anyone, self-hosted Linux machines. And we can see that we have a lot of executions of this benchmarker workflow. How do I kick a new workflow? I pretty much click this button here. I pretty much pass the name of the branch, in this case here, ANC 514, and I can pretty much pass the scenario file here and push the button. That's it. I can push the button and it will pretty much kick in the workflow. So I will kick in. Awesome. Luckily for me, I won't need to wait the workflow completion because I already ran it yesterday, right? The same scenario. So I can go here and I can see the execution. When I go to this execution, I can see that the workflow run three things, three child workflows or three child jobs, if you prefer, in the terminology of GitHub Actions, right? Actually, four, but one, the final one, aggregated results, is pretty much the last one. So when we go here into this view, we can see that we had parallel executions for the baseline scenario or the baseline status quo, if you prefer, the status quo or what we have right now in the master branch, and the changes that I am trying. In this case, changing only one number, 23 to 26. I changed only one number, right? That's it. I didn't put even the if there because, as I have shared before, I am not, let's say, committing here to any particular implementation details. I just wanted to learn how much can we improve and if actually we will improve or not. And yes, and then this execution took, I don't know, 20 minutes more or less, but I wanted to share here that this is a huge machine. It's not that huge, but okay, it's way more powerful than the previous machine that I had here, which was my 2018 MacBook Pro, right? So yeah, so eventually things are fast. In 20 minutes, I can get this result in a async await mode. And if I even pretend to run this locally, it would take maybe, I don't know, 3 hours in my local time. So no go for sure. Here in the very end, we have the artifacts. And then we have here the zip file, which is the output of this execution. I will download the zip file. Awesome. I have the zip file. And now I will pretty much open my Google Drive. Awesome. Inside my Google Drive, when you start using Google Collaboratory, Google Drive creates these Collab notebooks for you. And how we drive our experiments. We have a template notebook, and we pretty much duplicate this template before uploading the outputs from the workflow execution. In this case here, I already did it. So I have here the template me SDK 26. And I have this notebook open. And ta-da! This is a Jupyter notebook hosted inside Google Collaboratory, right? Awesome. Just to mention, I will answer all the questions after the talk, right? Because I saw some questions already in the Q&A, so feel free to share all your questions there. So here, yes, we have here, as I've mentioned, a Jupyter Notebook is a glorified way to mix Python code with Markdown code. Let's see here, and we call this in the terminology of notebooks, we do this inside cells. So let's open this cell. Oh my God, I see here Markdown. I can even expand this and see the code block. Oh my God. Let's remove this then and see what happens. Let's edit the details. Okay, I don't have the expandable block anymore. Awesome. Cool. That's it. This is a Markdown glorified way to do Markdown. Awesome. And we have some content here. We have other cells, and these other cells are pretty much grabbed when I duplicate the template. Here is a couple of commands, both shell commands and actually Python code. This is the way how we execute Unix commands here in this Linux machine. And here we have some very fancy Python code, right? So from the Aquila SDK, I am importing this class, and here I am creating an instance of this class. Awesome. And we have a couple of other cells, like here, an overview of the experiment, and here I can see that I will invoke a particular instance method from the interpreter. I have here a TLDR with a hidden cell. Then I have here interpreter.tldr, so on and so forth. So let's upload my zip file here. So when I pretty much open here the left bar, the sidebar, Collab connected here in the runtime. I can see here, right? So it's connected. And here I have this glorious free virtual machine that Google share with us for free, which is nice. Now I will upload my benchmark results. I downloaded the file twice because we never know if GitHub will be down, right? So then I won't be able to download. So I had here a copy beforehand. I have a reminder, uploaded files will get deleted when this runtime is recycled, which is fine because although the state of the virtual machine is deleted, Google Drive preserves the outputs of the execution. And then here I have the zip file with the results. So let's start executing things. First thing that I will execute is the setup for my notebook, right? And here we can see, do you see here this small green arrow here? It's pretty much the line being executed. Awesome. Can you see here what is happening? If you figure out here some bash kung fu, we can see that we are unzipping that particular file. And inside that particular file, we have the collection of the outputs of that particular execution. So I have the benchmark for what actually is in my master branch, and I have the benchmark for what I did in my head branch. In this case, one line of change, one number change, you know. So yes, so that particular cell executed with success, right? I can even see here inside Collab, I can see here the CSV file, right? Can expand here. So yes, so I have here the CSV file, right? And here I learned that I executed as a scenario, the benchmark for 2 single feature apps. Actually, the scenario files, I copied the scenario file, sorry, I copy and pasted here, right? So I used 3 warm-up builds, 50 interactions, and I pretty much applied some ABI and non-ABI changes in order to drive an incremental build. So here I have the benchmark CSV. Awesome. But I don't want only the benchmark CSV. I want actually to learn about my experiment. So let's execute the overview and figure out what happened. So I executed 2 Gradle tasks. Each Gradle task took, because one Gradle task per scenario, I got here a couple of warm-up builds, measure builds, and total builds per scenario, right? 36 builds per scenario, which gives me 72 builds in total. So yes, awesome. I have here a cell that is not supposed to be here. So what happened in the end of the day? If I execute this, I can see that, okay, I benchmarked 2 scenarios, and I can see 2 improvements. And Aquila even has a very naive way to drive the automated implementation based in the number of improvements, regressions, and non-conclusive outputs, right? In this case, data-driven from benchmarks supported the proposed changes, which means that for the TLDR, we are improving in the incremental builds by moving over SDK 26. How much we are improving? In this case here, I can drive the tabular comparison on top of pandas, and then this zoom mode is not that good, but I can see here, for instance, that we are eventually saving here almost 9% in the incremental build and almost 6%. We are talking about different apps. In this case here, Spaces is a super big feature inside the N26 app. Trading is not that a big one, I guess. But in both cases, we are improving. And we are improving with a p-value as small as 0. Because here I am rounding the number, and okay, it's almost zero, which means that we have, let's say, 99.99999% of chances that this particular mean is actually smaller than this one. And of course, I can have a chart, right? Why not? Awesome. So we don't have any inconclusive scenarios in this benchmark. We have here the chart for the two scenarios, both pointing to or assigned to scenarios with improvements. And here we can see that we had some noise in the sample, but I mean, we don't care, because in the end of the day, we have the parity test to figure out what actually happened. And yes, and we didn't face any regressions. Awesome. On top of that, I can finally finish my session, right, with my final remarks. Our journey so far, right? We built this automation. It took more or less 2 weeks of work from my end to build everything, including using our Terraform infrastructure to drive our custom self-hosted GitHub Actions Runner group, pretty much writing all the scripts, writing the Python SDK, etc., etc. But so far, we managed to run more than 100 experiments on top of this tooling, right? Which means thousands of our engineer minutes time saved in a sync-await style, right? Because it takes almost no time to pretty much download a file and then duplicate another one and upload the zip inside the notebook file. But most important, we have been managing to drive assertive solutions regarding our bit setup, right? With a more clear implementation path when we are delivering. And last but not least, we can validate any input from our Android ecosystem. And by ecosystem here, I mean release notes of libraries, tweets, subreddits, Google developers blog post, whatever. We can validate any input and figure out if that particular input actually works for us. And avoiding these, let's say, arguments of authority, or if you prefer this, ad verecundium, right? We don't accept arguments of authority anymore here. So if the Squire guy share with us that we can improve, okay, we can do a benchmark, we can pretty much drive our experiment, and we can have a reliable way to access that. And eventually figure out, okay, how do we drive this quick win? And that's it. So yes, this is pretty much my last slide. My name is Ubiratan. I am from Brazil. Here we have my socials. I am a Google developer expert for Android and Kotlin. And yes, feel free to ask any questions you want. Thank you so much for having me. Apologize for the bad English and also for the extra time, for being late.
Yeah, that was fun. Very, very good session.
Do you guys have questions? I see 2 questions in the Q&A tab.
Yeah, we have 2 questions. We can answer them, or we can wait like 1 minute. So if anyone has another question, we can post it now.
Okay, maybe we can start answering here. I see that we have questions both in the chat and also in the Q&A tab. So maybe we can start with Q&A and then going for the chat afterwards.
Okay,
so yeah, so we have here a question from Shalom with 3 votes. Are there any probability/statistics courses that you can recommend for approaching build engineering with your style? Answering no. No, but I can really recommend the courses from Khan Academy regarding probability and statistical inference, right? They are packed in a very friendly way with small videos and so on. So, and I watched a couple of videos of Khan Academy a couple of months ago, or I don't know, maybe 2 years ago, I don't know. when pretty much, refreshing that particular content. I have a background of computer science, so I had a lot of courses regarding statistics, mathematics during my university days in Brazil. They were my teachers were kind of, I don't know, super addicted into math. So yes, it was kind of, fun. But yes, eventually Khan Academy, it's a good place to start, I guess. And the second question from Q&A, can you please share your slides with the GitHub link? I will share my slides on my speaker deck afterwards, so you can grab my slides at speakerdeck.com/Ubiratan Soares, and then I think also the organization will be able to share. Oh, this is not a question. Cancel. Oh, here I am in the question. No, I don't want to share a question. Yes, that's it. So you can go to this link and grab the slides afterwards. And actually, there is also not a similar talk, but a talk around this content that I delivered 2 years ago in the online edition of DroidCon. It was in the very beginning of the pandemic, and we had, let's say, an online edition of DroidCon. So we have some content there. So yes, Shalom, I see that Shalom shared here some links from Khan Academy, so go for it. And yes, maybe I can go back in the chat and learn about and read some questions. Let's see. Okay, Aurum is a full stack tech wizard. I think yes. Let's see. Shalom, have you used Bazel before? That one was not for me. Are you on Chrome? Yes, I was, and I am right now. I hope you could see my presentation. Do you know? Let's see. Try another browser. Have you tried invalidation caching start all the day, all the time? This is always work, or supposedly work. Let's see. Let's see. I mean, we had a couple of questions here. I saw one question from Ryan, I guess, but now I can't find it. Not sure if Ryan can share the question again, or if you people can share the question again. The speaker has an enlightenment. I don't know what is this. Okay, supposedly yes.
Ryan was asking about his question. Do you find yourself having to make conversions to remain performant and secure on older Android SDK versions?
Right now, we have been investing into this DevSecOps training. We have some measurements in place, but we don't, let's say, benchmark against them, because when we handle security issues, we handle because we have to handle, and that's it, right? Security, it's a war impossible to win, and that's it. So we eventually commit with security solutions, even though some solution is not necessarily improving our Gradle build, but we have to do it. So not sure if I answered the question. Yes. All right. Not sure if we have any other questions.
Yeah, I think we are done with the questions. So lastly, we need to thank you. A very fun and informative session. We would love to have you back.
Cool. It was a pleasure, and feel free to reach me out on Twitter or LinkedIn or whatever, and let's have a chat and enjoy the rest of the conference.
Thank you.
See
Okay.
you, people.